Hi guys, welcome to the webinar on data science with R. I'm Yasna Rafat. I'm a data science consultant, and I'll be handling this class over the 15 days. So first I'll introduce you about the program. The program is about data science with R. So data science, first here we'll cover about what is data science and why we are using R language in spite of many other languages that support data science like Python, SPSS, but we'll be using R. So why to use R, we'll be looking at it. So I think everyone's fine starting the webinar right now. So I'll start with the webinar. So what is data science? What is data science? So if you see what is data science, so data science is a field. Data science is a field in which that involves computer science, that is your hacking skills or your programming skills, your mathematics skills, so your statistics, analysis and mathematical skills, and your domain knowledge. So when you have all these skills put together, then you can be called as a data scientist. So some people might have only computer science, that is programming skills and mathematical skills. Some might have mathematical skills and domain knowledge alone. So mathematical skills and domain knowledge alone, you can be called as a business analyst. If you have domain knowledge and hacking skills or programming skills alone, then you can be a product manager. But still, to become a good data scientist, you must possess all the three. You must possess all the three. So a data scientist will be able to handle structured data as well as unstructured data, and using the data that is given in the past. Using the past data, you'll be able to predict the future. So what we can expect in the future. So all these things can be done by a data scientist. So data analysis, so you'll be doing some data analysis and using some machine learning algorithm on this. Some machine learning algorithms like naive Bayes, very simple algorithms which involves like probability, up to some complex algorithms like neural nets. So depending on the data given, which algorithm to use. So you'll be deciding on it and you'll be using them as well. So here, what is data science? Is it new? So many people do not exactly know what is data science. So, but there is a very good answer given by Michael Driscoll. So he says that data science is a blend of hacking as well as some statistics. So when you know hacking or programming and statistics both together, when you apply it in some domain, then it is called as data science. So although this term data science is coined only few years back, there have been data scientists who have been even before that. So people who made use of the data to bring some changes in their field. So for example, you would have heard of, I believe most of you would have watched this movie Moneyball. So there a sports manager who uses data and forms a team of average players. So using these average players and guiding them properly based on the past data of the other players. So he'll be qualifying until the finals. He'll be qualifying until the finals of the game. So this way, anyone who can use data in their field, anyone who can use the data in their field to bring some changes or to predict something. So he is called as a data scientist. Now you can see the second point here. So second point means that only if you know programming, you are not a data scientist, because programmers do not care about the distance metric, which is the mathematics behind it. And if you know the mathematics behind it, if you don't code, then you are just a statistician. So a data scientist should be comfortable to code as well as he should be comfortable in statistics. So if you see here, a data scientist is this job is said to be the sexiest job of the 21st century, and it is transforming insights for making better decisions. Many companies are using analytics right now. However, most of the companies do not know how to use the analytics or how to use the data. So if you see in the last few years, the data has been accumulated. So after the concept of big data, now every company can afford to store so much data. So when I have more and more data, using these data, I can come up with better and better decisions. But how do I come with this better decision? So this person should be very good with insights. So using the data, so which are the fields that I'll require, which are the fields that I'll not require, you should be able to differentiate them. So once you differentiate them, then you will become a data scientist. And so there is a very good scope for data science right now. Reason is because many companies are starting to adopt data science, and many companies are starting to use data science to give better product experience, to the customers and their clients. Now I'll be telling about what our course deals about. So everyone knows that here big data, only after big data the data analytics has become very popular. Earlier also the role of data scientist used to be there, but however the term data scientist was coined only very recently. So earlier, for example, when you are working in the BPO industry, you'll be predicting, so what is the conversions that you can be doing. So such kind of people were called as business analysts. However, now what happens is that earlier the data will be given to you, but nowadays you will have to collect the data. You will have to collect the data from some reliable field or from some reliable places or any place that you can get the data from. So what our course deals with is first collecting the data and understanding the types of data. So some of the data may be numerical, some of the data may be non-numerical. So how non-numerical attributes you can use in programming. So what are the types of data and what are the types of data analysis. The data analysis, it may be inferential statistics or it may be descriptive statistics. Using this you can predict. So all these things you will be looking at. And how to use R. How to use the R language. So what is this R language? How to use this R language for analyzing different types of data or different file types. Sometimes the data will be given to you as a XML file, sometimes it will be given to you as a JSON file, sometimes it will be given to you as a CSV file, sometimes it will be given to you as an Excel file. So how to load all these different types of data into your R and do some analysis on it. So now if you see, some visualization companies have become so much popular. So in R, basically what we'll be doing is that first we'll be learning how to use a data in R, how to load a data, how to understand the data, how to classify the data. Once you classify, how to use the data to come up with better decisions. Sometimes your learning may be supervised learning, sometimes it may be unsupervised learning. So what is supervised learning? For example, let's say I give you the previous sales record of a supermarket for the last 2 years or 3 years. So the sales record of a supermarket for the last 2 years or 3 years I will be giving. Using this data, I will be able to predict what will be the sales for the next 3 months or 4 months. So when I have the previous data, what I will be doing, I will be using some model to find out how the output, that is your sales, how your sales is dependent on the other factors. The other factors like, was it a rainy day? If it is a rainy day, how much business did happen? If it is a non-rainy day, how much business did it happen? If it is a sunny day, how much business did it happen? Then in different seasons, so if it is summer season, what is the sales? If it is winter season, which kind of product sells more? So these kind of things, your machine will learn from the previous data, previous 3 years data or 4 years data, sometimes even more than that. So when you learn from the previous data, you can actually apply it to predict the data for the future. Well, after learning from the previous data, you can predict it for the future data. So how to do this? So this will be your supervised learning. And next there will be unsupervised learning. So what is unsupervised learning? Sometimes you will not have the previous data. Only using the data that is about to happen. So only using the data, you will be predicting what is going to happen. So this is unsupervised learning. In supervised learning, you will be having the data history. That is, if this is the outcome, how the outcome can be related to the inputs that we are giving. So this is given means it is a supervised learning. If it is not given, it is unsupervised learning. In unsupervised learning, most of the times we'll be using some basic probability and statistics, and we'll be coming up with some models for this unsupervised learning. Then we'll be learning about hypothesis testing also. So in this hypothesis testing, what happens is that, let's say you are predicting something, you are building a model, you are predicting something, and the event has happened. So how good was your prediction? How good was your prediction? So you can use hypothesis testing, or you can use some other ways to find out how good the model was built. And after this, you can see next time when you are predicting, you can make use of this data. Next time when you are predicting, you can make use of this data to come up with better predictions. So how we will be doing this? And there is this cross validation. So when you build more than one, you can build more than one model and mix all of them together, and you can ensemble them also. So how to do all these? So all these will be covered in this course. So in the course, basically what will be covered is that the first part of the course will contain some statistics and mathematics. So the basic statistics concepts that is required for data science will be covered as a first part of the course. So while doing that, side by side, we'll also be learning how to do this analysis, how to do this statistical distributions on R. So once we are clear with this, after we are clear with how to use this basic statistics commands in R, we'll be starting to build some models. We'll be starting to build some models on how to use the data to come up with some decisions. So we'll be using some models. So once we do some models, finally we'll be having a small project. Maybe we'll be doing a Kaggle project. So everyone here would be aware of Kaggle. So Kaggle is the database for most of the data scientists who are starting to learn. And the Kaggle contest can pay you even like $30,000 to $40,000 for cracking up data and coming up with better decision. So this is what the course deals with. I hope everyone is clear of what you can expect from the course. Is there anyone with any questions about the course? If you have got any questions, you can now tell me in the chat window. You can ping me in the chat window. First thing, how to gather the data. You can gather the data from any source. Sometimes the data will be given to you. Sometimes you will have to gather the data. So how to gather the data, how to understand the data, how to do some analysis on the data, how to present the data. By presenting the data, I mean visualizing or creating some interesting plots. That shows the relation between two fields. For example, sales. So there is one small data set that we analyzed. So that data set is for an NGO. An NGO which talks about what happens to the dogs and cats. So the pets, basically, if there are any pets that are sent to the homes, animal homes, so what happens to them? So some of them might be adopted, some of them might be transferred, and some of them might be killed also. So we had to analyze this kind of data, and after analyzing this kind of data, we'll be giving the result. For example, if a dog is arriving right now to my animal home, what is going to happen with the dog? Is it going to be sold, or is it going to be transferred? So like this we'll have to do. For example, if a dog has a high probability of getting adopted by someone else, then I can actually increase the price of that dog. If a dog cannot be adopted, so if I predict like a dog cannot be adopted, or a dog has very low probability of being adopted by someone, then I can actually decrease the price of that dog and sell them, so that the chances of it getting adopted might increase. And this way I can do many other analysis, and using these predictions I can come up with some decisions. Using these predictions. In this, we found that there was one very interesting relation between what happens to the dog. Is it being adopted, or is it being transferred, or is it being killed? So all these things, so this is exactly dependent on so many other factors. So factors like the breed of the dog, and where the dog is from, and the size of the dog, the age of the dog. So based on all these data, it was dependent. However, one interesting fact is that it is also dependent on the name. It was also dependent on the name. So if the name of the dog ends with any vowels, if there is any vowel in the last two characters, we found that people usually are attracted to that kind of names. So whenever only kids used to come for adopting dogs, so when the name of the dogs ends a bit cuter, there is high probability that the kids started liking the dog and they start adopting it. So this is one kind of relation that we found. So in this animal adoption, in this animal home data set, and this is the kind of models that you will be building. So sometimes we can say that the breed of the dog will definitely affect what would be the outcome. So these kind of things are already known to us. But however, very few of us would have found that the name of the dog also plays a role in predicting what is going to happen with the dog, whether it is going to be adopted or whether it is not going to be adopted. Even the name of the dog has something to do with it. So even these kind of things we can be building using these machine learning models and data analytics models. And we'll also be building some recommender systems. If you are buying a product online, let's say you are buying a mobile phone online, you will be getting recommendations. So people who have brought the mobile phone have also brought the mobile case cover, or they have also got the screen guard. So things like this, you'll be getting some recommendations. People who have got this product also got another product. So you'll be getting some recommendations to the other products. However, if you are buying a mobile screen case or mobile case, if you are buying a mobile case, the system should not ask you to buy a mobile phone also. So if you are buying a mobile case, it means that you already have a mobile phone and you are looking for a case for that mobile phone. But if you are looking for a mobile phone, it means that you might also require a case. So this way the system should understand so how the products are related. So if you are buying the first product, you may or may not buy the second product. If you buy the second product, you definitely will not buy the first product. So these kind of relations will be established and some recommendation systems will be given. Now recommendation systems are also based on the brands. So different brand, people preferring this mobile phone in this area, which brand do they prefer? So this type of recommendation systems will also be there. We'll be looking at how to build those recommendation systems as well. Now where can data science be used? So you can see here, the screen says that the data science can be used in gaming industry. So in gaming industry, you can see the game start time and average time is given. So how many people have started the game? How many people have ended the game? What is the average time spent by each users on every levels? So there are somewhere around 1 to 25 levels are there. If you look at this, the number of people keeps decreasing. If you see the first figure, the number of people cracking the first round, second round keeps decreasing. If you see somewhere close to the 10th and 11th round, in 10th round to 11th round, there is a very steep decrease. 10th round to 11th round, the number of players playing the game, there is a steep decrease in it. And again 11th round to 12th round, there is a steep decrease. Here in the average time, you can say that 11th round to 12th round, there is a steep decrease, which means at 9th round to 10th round, there is a steep increase. Again 10 to 11 also, there is an increase, which means that I can say that the 9th round and 10th round are a little bit difficult. The 9th round and 10th round are a bit difficult. So people do not want to play after the 9th round. So this is one prediction that I can do. This is one assumption that I can have. And based on this assumption, I can make my game a bit easier on the 9th round. So when I'm doing this, I can definitely say that there is a probability that the decrease in the people playing the 10th round might decrease. And there will be more number of people who will be playing beyond the 10th round. That is 11th round, 12th round and 13th round. There will be more number of people who will be playing them. So this is how data science can be used in gaming industry. Apart from this, you also play some online games like online poker and all. So where again data science is used, a lot of data science is used in it. You can see this is how analytics is used in sports industry. So this is a graph. This is a graph demonstrating how the shots are played by Federer and Murray. So the green color represents the shots, the movement of Federer, and the green dots represent the winning shots of Federer. And blue color says about the winning shots of Murray, and the blue lines represent the movement of Murray. So how their movement are they, and from which points they are giving the winning shots. So they'll take the data from this game and they'll analyze it. They can definitely use it for the next game. They can definitely use this kind of data for the next game. So this is a statistics in a football match. So in a football match, you can see the different players and what is the total distance run by these players. What is the average speed of these players? So how much distance did they walk? How much distance did they jog? So these kind of data are given, and based on this data, they'll be doing the player analytics also. So which player is worthy, which player is not worthy, how many passes did they give. So you can see the total distance, total HR plus sprint, total sprint distance, average speed, passes. So there are like 252 out of 331 passes, 2 crosses, and 2 out of 8 shots are goal. So these kinds of data are given, and we can definitely use this data to do some player analysis. So which player should improve, which player should not improve. So these kind of data analysis we can definitely do and come up with some decisions. Same way this can be used in many other sports industry also. Here I have just showed you examples of gaming industry and tennis and football. It can also be used to in other sports industry as well. Apart from sports, it can also be used in other industries. If you see this is a very simple example of how you use basic probability to predict, which team is going to win a game. So if you see this screenshot is a game. This screenshot is a game between Sri Lanka and another country. So here you can see some statistics. So outside Asia since 2011, if Sri Lanka restricts Australia, so there's a match between Sri Lanka and Australia. If Sri Lanka restricts Australia to less than 275 runs, then there is 86% chances of winning. The second statement says that Malinga, if he takes 3 or more wickets, there is 75% chances of winning. And if Malinga concedes less than 5 runs per over from the 11th to 40th over, then Australia win 81% of the matches in home. When they score more than 5, if they score less than 5, there is 81% chance that they will not win. So here 81% chance that they will win if they are scoring more than 5 runs per hour. So using this data, what I can do is that I can build something called as a Bayesian belief network. So you might be aware of Bayes theorem. where you will use basic probability. You will be using the basic probability, the conditional probability and things like that. You will be mixing them all up and finding the final probability. Now we can see that in the 11th to 40th over or whatever match is going on, we can collect so much data. So these are only very few data. You can see the next one. So here, how Kohli's contribution is there in winning. So 60.4% contribution in winning, 80.8% adaptability, and some other numbers are given like this. So this way, more and more data should be collected from the previous games. So since 2011, what all games Sri Lanka has played, what all games Australia has played, we can collect all these data. Once we collect all these data, we can use all these data to build some simple probabilities. If the first player, this player gets this many wickets, what is the probability of winning? If this player scores this many runs, what is the probability of winning? If in this over this many runs are made, what is the probability of winning? If this is the target, what is the probability of winning? So if the pitch kind is dry or if the pitch kind is dampened, so what is the probability of winning for this team? So this way I will be collecting so many data. And I'll be mixing up all these data to do some predictions. And you will be wondering on how to do this. These are done using very, very simple probabilities. Just by multiplying the probabilities, we will be coming up with decisions like this. Same is the case with predicting whether it will rain or not. Predicting the weather. So if we collect enough data, about our surroundings, as well as the past history data, so past data for the last 1 year or 2 years, using that I can say if this was the condition yesterday, today will it rain or not? So today what will be the condition? So most of you using smartphones would have observed on the beginning of the day, there'll be a statement that today it is going to be dry, or today it is going to be sunny, today it is going to be rainy, mild chances of rain are there. So this type of notifications you might be getting. So these are nothing but predicting. The system predicts what is going to happen. Mostly it is based on simple probability. Most of the times it is based on simple probability only. It can also be used in analytics, is also used in supply chain management industry. So there is this simulations. So you'll be learning about simulated annealing, gradient descent, and techniques like this. Simulated annealing and gradient descent techniques like this, which can be used in analytics and supply chain industry. So using these, you will be finding the shortest path. In supply chain industry, you will be finding the shortest path, or when the demand will be there. Sometimes you can even use that for fixing the prices, dynamic pricing. So based on the demand, what is the price that you can fix? And what is R? If you see, R is a very simple tool. R is a very simple tool that is used for statistical computing and graphics. So why do we use R? The reason we use R is that R has more than 4,000 packages that are inbuilt already. So we can just use these packages to build some models. If we want to build a linear model, non-linear model, or if we want to do some classification, if you want to do some time series analysis. So where time series analysis will be used means it will be used in predicting the stock market price. It will be used in predicting the stock prices based on the previous data. You can use time series analysis for it, or you can use clustering. Clustering you can use for recommendation engines. So to do all these and also to visualize, so there is something called as Shiny. There's a package called as Shiny. There's a package called as ggplot2. So what these plots will do, it will allow you to plot. If the data is given, how two fields of that data are related. So you can show them in very simple plots. So all these things are available in R. That is the reason we are going with R. And R is very easy to understand. R is very simple. It is easy to understand. And that is one more reason why we go with R. So if you see, R is the most widely used data analytics software. As of now. Python is fastly gearing up, but still R is definitely the market leader when it comes to the software used for the statistical tool used for data analytics. And it is flexible and it has extensible support. So even if you want to connect it to big data technologies like Hadoop or Spark, you can use R. You can use program with R for big data, MapReduce, as well as Spark also. And R is open source. So there are too many contributors. Let's say you come up with some idea to implement some new concept in R. You can definitely contribute to R. And what R can do and what R cannot do. So you can see R can do data handling. So be it different types of data, it may be numerical data or textual data. R can do data handling. It is not a database. It is good with matrix calculations. So if you see R is specifically built for working on large data sets. So the calculations that you do on R will be faster than any other programming language. But however, R is basically built with C and C++ only. If you want to include a package or new concept in R, you can either program with R or you can program with C or C++ and then connect it with R. That is also possible. You can use classes in R. However, as a statistician, we will not be learning about how to use classes and the object-oriented concepts in R. And R has very good support for graphics. So there is this library called ggplot2, ggplot and ggplot2, which can help you to build very good interactive graphs. For much better interactive graphs, there is another package called as Shiny. We'll be learning at the end of the course how to use these packages. So R and statistics. So most of the packages that are in R. So a package is nothing but a contribution. Let's say I want to build a linear model, linear regression model. You don't have to code for the linear regression model. So there will already be a package in which how to build that linear regression model. It will already be recorded and the code will already be there. What you have to do is that just include the package and write one line of code. Just write one line of code to find out to build the model. So that is one huge advantage with R. Most of the data analytics, if you see, most of the analysis, if you see, most of them will be only one line of code in R. Reason is because all the concepts are already implemented and available to you as a package. All the statistics concepts and the data modeling concepts are already implemented and available to you in different packages. The only thing you'll need to do is use those packages and use those models. That's it. So if you see, the popularity of R keeps on increasing. The popularity of R keeps on increasing every year. So if you see, compared to 2008, so R has continuously increased since 2000 up to 2013. Now if you see, even now it has been in the steep increase only. So even in 2016 the use of R has been in the steep increasing, and in language popularity also R ranks in the 9th place. In language, even in language popularity, R ranks in the 9th place. If you see Java is used for application development, mobile application development, or your Windows application development. It can also be used for data analysis. So by using for all the three purposes, Java, C, C++, Python, all these can be used for all the three purposes. But however, R, if you see, it is mainly a statistical tool. R is mainly a statistical tool built for the sole purpose of, although it supports object-oriented programming, most of the purpose of R is used as a data analysis tool only. Now R has even become more popular than MATLAB. So if you see here, R is used 43% by, so in a survey it was told that among all the data scientists and non-data scientists, so data role and non-data role, when there was a survey, among the 100%, 42 plus 29, which is 71% use SQL, 43% use R, and only 41% use Python. So in this R, 33% of the time people use it for a data role and 10% of the time for a non-data role. So this is, looking at this, you can definitely say that R is one of the most popular data science tool. Python people mostly use, extensively people use Python only for text mining and image processing. So R is also good at text mining and image processing, but however Python is much better. MATLAB is also popular. MATLAB is also popular, but however, so for the role of data scientist, so this is people working on data science. In data science, you may be a visualization engineer, or you may be a model builder, or you may be a machine learning engineer. So among all these people, MATLAB is not there in this list, but however, I'm quite sure that MATLAB is also used. MATLAB is also used by many of the data scientists right now, but it is being quickly replaced by R. Is being quickly replaced by R. Now, if you want to work with big data, you must be good with some programming and scripting. But R is not like that. R is a very, very simple tool. you can see which are the highly paid skills and experience. So average salary. So you can see R is among the highly paid IT skills in the USA. So the average salary for R is $115,000. $115,000. So if you see, there is the other skills, NoSQL, MapReduce, which are part of big data. So MapReduce is a part of big data. NoSQL is again a part of big data. Cassandra is again a part of big data. Big, Hadoop, MongoDB. So all these skills also pay somewhere very close, but still R pays you the highest. R pays you the highest. So right side, if you see, you have a graph. So if you know R, you'll be getting paid very good. If you know big data, you'll be getting paid very good. If you know both of them, then the package is much higher. So you can see R ranges in the second place. Where your average salary will be from $110,000 to $125,000 per annum. And this is the growth of R. So there is another tool called as SAS. SAS, however, is not a freeware. SAS, however, is not an open source tool. R is an open source tool. Because it is an open source tool, there are so many contributors for R. There are too many contributors for R. For example, if you come up with some concept, a new implementation of an implementation of a different type of distribution or a different idea, you can definitely implement it, and you can give it for everyone to use, because it is open source. People can actually use your package and use your idea. So these kind of things can be done using R. So you can see this. R is open source. It is very powerful language for data manipulation, computational statistics, and machine learning. And in this course, we'll not only be learning R, we'll also be learning something called as H2O. So what is H2O? H2O is a platform for machine learning. So we'll be seeing how to connect this H2O and R, how to use the data from R in H2O to use some machine learning models on it, like neural nets, deep learning, deep neural nets. All these things we'll be using H2O to do. The basic modeling, if you see, R is very good at doing. If we want to use some advanced machine learning models, so it is always better to go with some machine learning platforms like H2O or Mahout. So in this case, in our course, we will be learning about H2O also.